tonight.
Can you hear me?
Yeah, I can hear you just fine.
Okay. How's it going?
Good. So what are we working on tonight?
Factor theorems, remainders.
Okay.
I'll email it to you.
What was the other one?
I said I'll email it to you.
Oh, okay. So the zero remainder theorem and the rational factor theorem?
Pretty much we're doing like synthetic division and long division.
Right. All of which employ that.
Yes.
Mm-hmm. Okay. Let me know when you've sent it.
Okay, one moment.
Yeah, this is fun stuff when you're trying to find the zeros of cubics and quartics.
Sent it.
Who knew how tough it was to do, huh?
Yeah, it's a little rough.
No, it's mainly just really complicated. As opposed to solving quadratics. You know, quadratic ends up being a piece of cake compared to cubics.
Mm-hmm.
Where would you like to start?
I'd like to start on number 4.
Most important thing, whether you're doing synthetic or long division, is to always put in a degree polynomial of every kind. In other words, what do you want to do this by long division or synthetic or both?
I could do either, or I think synthetic would be quicker.
Okay, what do I put in the box if I'm using synthetic?
-2.
All right. What do I put across the top?
Would I put 1?
That's for that term.
Then the teacher taught us to like put an arrow under the 1.
Well, first of all, fill out the string of coefficients that go across the top. And
Okay.
I need a 0, which represents the number of x squareds. Notice there aren't any x squareds.
True. Then there's a -4.
Yeah, now whether I need a 0 for the constant or not, I'll put 1 in. Because there's no constant either. Okay, now what your teacher meant when he said draw an arrow below it is that's always the first step, is to bring down that number, whatever it is, and write it there.
Mm-hmm.
Okay, now what?
Multiply 1 by -2, which would be -2.
And write it there.
0, then -2 plus 0 is -2. Then -2 times -2 is 4, then -4 and 4 equals 0.
Okay. It doesn't look like on this particular problem I needed that 0 over there, but it actually still works okay. And you know what? I'm going to leave that 0 there because I'm not done yet. I got -2 times 0 is 0. Add those. There's my 0 remainder. That tells me that this was a linear factor of this cubic. And what's left over? In other words, I've got x plus
Squared.
2 times what?
0.
What does that 1 represent right there? That's the remaining quadratic. So that would be x squared, because of a 1, minus 2x and no constant. So if I multiply those two by that, I will get what we started with. Can I do any more factoring? What exactly are we supposed to, we're just supposed to come up with an answer, okay?
Yes.
Well, that's actually the answer. When you divide x cubed minus 4x by x plus 2, you get x squared minus 2x. Let's see if that's true. Let's multiply it back together again, foiling it. Got this, whoops,
X cubed
minus 2x squared plus 2x squared minus 4x. Those go away, and you're left with that minus that. Okay. I think that this 0 was necessary, and this term here is where the 0 factor or the 0 remainder thing, it's this 0 that tells you that that factor was indeed a factor. In other words, there's no remainder left over. If there's no remainder left over, then that's a factor. Okay. And let's do at least 5. We'll start. Find f of c using the remainder theorem.
I have no idea how to do this one. How would I substitute?
Well, hold on. I'm trying to figure it out what they're talking about. Using the remainder theorem, see if 2 well, it says find f of c. Okay? It's actually very straightforward. If f of x is x cubed plus 6x minus 7, what is f of c?
That's 2.
C cubed. In other words, I'm going to substitute c wherever I see an x.
Okay. C cubed plus 6c minus 7.
And now they're saying if c is 2, well, what is f of 2?
2
cubed plus
minus
times 2 minus
7.
So I believe that's all they want here. I'm not quite sure. Would x minus 2 be a solution? What is this? This is 8 plus 12 minus 7. That's is 2 a 0?
Is 2 a 0?
Uh-huh.
I have no idea.
No, it isn't, because it doesn't equal 0. In other words, actually, I think I have an idea of what they're trying to get to here. Let's back up a little bit. Just because of this part up here, find f of c using the remainder theorem. I'm not quite sure what they mean, but you can certainly find f of c by putting a 2 in there and doing synthetic division. What goes across the top?
1. Then it would be 6 and negative 7.
0. There's an
0.
There's an x squared missing.
Okay.
That has to be accounted for. Okay, now I'll do it just because this is just arithmetic. Notice what the remainder is.
13.
Since it is not 0, 2 is not a 0 of this solution. And I also found that out by just substituting 2 in for x, and I got 13. So if I'm attempting to see whether that is a 0 or not, I can always use synthetic substitution just like this. And if I get a 0 in this last square down here, then that is one of the zeros. 2 is one of the zeros.
Okay.
Okay, so let's try number 6. We'll go across the top.
1, 0, negative 47, negative 16, 8, and 52.
Is that a solution? Is 7 one of the... In other words, is x minus 7 a factor of that polynomial? If you divide, what they're saying is if I divide that polynomial by x minus 7, will it divide evenly? Or will there be a remainder? Now, this tells me there's a remainder. It means it's not a factor and it's not a 0. Have to have this thing be 0 in order to consider that a factor. Now, number 7.
Okay, this one.
Possibly want us to do on number 7. Is that a typo? In other words, they got a polynomial here that hasn't been simplified even. That's a minus 17x plus 2x.
We might have to simplify it possibly. Would that work or not?
Well, yeah. I'm just trying to figure out what they want us to do with that c minus 3. I'm not sure. We have answers on this?
Unfortunately not, but I'm pretty sure my teacher said you flip the sign of the number in the parentheses.
Yeah, in other words, put in plus 3 in there.
Yeah, and then do synthetic division that way.
Right. That's what I would have thought we had to do, but it's not at all totally clear that that's what's going on here. In other words, this didn't say c plus 7 or c minus 7. In other words, if we're going to do what you suggest, you're suggesting we put a 3 in there, right?
Yes.
So how come this doesn't say c equals 3? In other words, in number 6, it said c equals 7, and so we put a 7 in the box.
Yeah, you're right.
I'm a little confused, but let's do the math and see if... So what goes across the top?
1, 0, 3, negative 17.
1, 3, 0. Have to always make sure you keep them in order. This is the x to the 4th term. This is the x cubed coefficient. This is the coefficient of x squared. There's that many x's. And there's that constant.
Okay.
So let's see if this produces a 0. Not very promising at the moment. No. Big number, not 0. Big number. So none of these 3, 5, 6, or 7, was that... I'm wondering whether they want us to find f of c minus 3 I don't know. Let's not spend any more time than we have to on it. Let's keep going. Yeah, we got more questions regarding that. Given the function f of x and the factor x minus c, okay. Use the factor theorem to determine if the binomial is a factor of the function. Write yes or no and state why or why not. Okay. Again, we're not using the rational factor theorem. When they say the factor theorem, I guess maybe they don't mean the rational. Have you had the rational factor theorem?
No, I don't. No, I haven't.
The rational factor theorem says that if you have a cubic and there is a rational factor, its numerator is a factor of the constant and its denominator is the factor of the coefficient of the highest degree term. That's what it says. Okay, so that apparently is not what this factor theorem refers to, but this is pretty straightforward, this question. And that is, right, yes or no, is this binomial, x plus 3, is that a factor of that polynomial? Goes in the box.
Yeah.
It's the easiest way. You could divide it. In other words, you could do long division. You want to try a long division one just to make sure you understand how to do long division on these?
Sure. There's a bunch of long division on the top.
There is? Okay. Let's do long division then. Because there's really no difference. You have to do the same things. In other words, you have to account for every degree of x, but they're all accounted for in this problem. I don't need any dummy variables. But I would put one in. In other words, if there was no x squared term, I would put in 0x squared. Okay?
Okay.
The first step in the long division process.
Say again?
What's the first step in the long division process?
I have to see what makes x into x cubed.
So all we have to do is divide that into that. Don't worry yet about the plus 3. In other words, the very first step is always dividing that into that. Well,
X squared.
Squared. Now multiply that x squared by both terms. So you get x cubed
plus 3x squared.
And now we're going to be subtracting the whole way. Okay.
So then
notice if we were doing synthetic division, this would be a -3, right?
Yes.
And we would be adding the whole way. The reason it works that way is because the variables aren't important here. It's just all the numbers. And since we're using a plus 3, we're going to subtract. So when we do our first subtraction, we get that. We bring down the next term and repeat the process. Every time, do exactly what you did the first step. In other words, divide that into that.
So 6x.
Correct. Now multiply the 6x by both terms.
6x squared plus 18x.
Now subtract.
So then that would be 5x.
What goes up here now?
5.
Correct. And now when I multiply it back together again and subtract, I get 0 remainder. That tells me that that is a factor of that. In other words, x plus 3 times that quadratic gives you this cubic.
Okay.
Okay, so we've answered A. I'm not sure we've used the factor theorem, but I'm not sure. Yeah, I guess we have. Write yes or no and state why or why not. Well, the answer would be yes, because there is a 0 remainder. See,
Okay.
the two theorems I'm familiar with are the zero remainder theorem, which is what we used here, and the rational factor theorem, which is a process for determining what the zeros are. But it's a trial and error process. All right, let's see what they want for B. If the binomial is a factor, use it to write the complete factored form. Okay. So at this point,
X plus 1.
well, at this point, let me erase this stuff. We know that our two factors are right there.
Yes.
So factor that quadratic.
X plus 3, X plus 5, and X plus 1.
Those are your three. That's completely factored. When it says complete factored form.
Okay.
Okay, you factored it down to three linear factors. Now, sometimes you'll factor it down to two linear factors and an irreducible quadratic. In other words, let's say at the end of the process I had this. I cannot reduce that any. I can turn it into imaginary numbers, but I can't reduce it. So that might be an answer for some of them, as they usually have you take it down to its linear factors and a irreducible quadratic if there is one. Now, of course, if I change that to a minus 1, I can factor that. But as long as that says x squared plus 1, I can't factor it. That's always positive. That expression has no zeros. In general, the problems you're going to probably be looking at here are going to give you three linear factors.
Okay.
And there was only one problem. No, it says 8 through 10. So they want us to do the same thing on 9. Okay, this time, let's use synthetic. I think you can kind of see that once you get comfortable with synthetic, it's easier. It's quicker. You don't have to write all those variables. Goes in the box.
3.
What goes across the top?
0.
1.
Wait, 1, 0.
Huh? Not 0. There's an x.
What would be next?
There is an x squared term. What's its coefficient?
Would it be? Oh, it's 1.
Negative 1.
Negative 1.
It's the coefficient of the x term.
The coefficient of the x term is negative 14, and that's 12. Wait, okay, now I get it.
Okay, cool.
Okay, now I understand why that exists. Like, because before, I just memorized how it worked out, but now I understand how the numbers come to exist.
Yeah, it's the coefficients of that polynomial.
So it's all in order of the coefficients. Okay.
It's all about the coefficients. If a term is missing, then its coefficient is 0, right?
Mm-hmm.
Okay. So,
then it would be 3, and then I'll make it 2. 2 times 3 is 6. Then negative 14 and 6 is negative 8. Then that'll be negative 24, and then that makes it 0.
Okay. So what are the two factors we have at the moment?
X minus 3.
Is one of them. What's the other one?
And
it's always whatever you get below the line.
X minus 3 over 0.
No. This is always going to be 1 degree lower. So if this was a cubic, this is going to be a quadratic.
It's x squared.
Right. In other words, this is the coefficient of the x squared. That's the coefficient of the x term, and that's the constant.
Minus 8.
Okay. So, in other words, x minus 3 is indeed a factor. The answer to A is yes, and the reason is because it produces a 0 remainder. And now fully factor it.
And then a factor of that would be, it would be negative 4 and, no, it would be positive 4 and 2, negative 2.
There you go. So your three zeros are 3, negative 4, and positive 2.
Okay.
Okay. Now, let's say that that's a 7.
Yes.
That's where we're at, in other words. Well, now you can't factor that, but you can use the quadratic formula on it. So if I use the quadratic formula on that, I got minus 2 plus or minus the square root of
E squared minus 4ac. So
4 minus a minus 28. So that's all over 2. So now I have minus 2 plus or minus the square root of 32 all over 2. And that is minus 2 plus or minus, I'm going to take a 16 out of that. So I got 4 root 2 over 2. Cancel the 2's. That becomes a 1. That becomes a 2. So now here's my factors. X, in other words, here's my answers. Let me make this a little cleaner. When I used the quadratic formula, I was saying X was equal to these things. So here's my two answers. X is equal to minus 1 plus 2 root 2. And X is equal to minus 1 minus 2 root 2. Okay?
Okay. Yes.
So now, what are my other two factors?
The other two would be, it's like a problem.
In other words, if that was a 7, then I would have to use the quadratic formula. Well, these factors are always x minus this, right?
Yes.
So that's what it is. X minus the quantity minus 1 plus 2 root 2. And x minus the quantity minus 1 minus 2 root 2. So those are your three factors. Now, you can simplify this a little bit. In other words, I can pull out the inside parentheses. Let me do that. So that's going to be x plus 1 minus 2 root 2. And this is going to be x plus 1 plus 2 root 2. So there's your three linear factors. They're still linear. It's just that this is irrational, whereas that one's rational. That's the only difference. I still have three linear factors, and if I multiply these three together, well, I'll get back to this step, and then I'd multiply that by that to get back to my original cubic. But all I'm saying is that when you get it down to this quadratic, sometimes it might not factor perfectly, and we have to use the quadratic formula, and changes the appearance of your answers, kind of. Because this looks like a trinomial now, even though it's really not. But all right. Number 10 looks very straightforward.
Yeah, I just put negative 2.
Yeah, negative 2. If you get a 0 remainder, see if you can factor the quadratic. Now, if this quadratic turns out to only have imaginary solutions, then leave it as an irreducible quadratic. In other words, make that a plus 7, and you can't come up with anything but imaginary solutions for this quadratic. So this is actually your final answer. They don't want you to come up with the imaginary solutions and make it x minus whatever that imaginary solution is. You could, but they don't want that. Whenever you're factoring these polynomials, you always bring them down to linear factors and irreducible quadratics if you have one. And that's a quadratic that won't produce anything but imaginary solutions. And that may be the case with 10. I don't have time to do 10, but you can probably figure out pretty quickly. Maybe 10 is one where the answer is no to part A, and then there's nothing left to do. And
I just finished it. The remainder is 0.
What's that?
I just finished it. The remainder is 0.
Okay, and what's the remaining quadratic? So we know that x minus 2 is a factor.
Yes.
What'd you get for the rest of it after the synthetic division?
10, 17, 3, and 0. Total.
What are they?
10x squared, 17x, and 3.
Is it plus 17x?
Yes.
Plus 3?
Yes.
That looks like it factors into 5x plus 1 times x plus 3. Oh, no, it doesn't. No, there's one that doesn't look like it factors very nicely.
No, definitely not.
Okay, so we're going to have to use the quadratic formula on this. Whatever you come up with, handle it the way I just showed you.
Okay.
Okay? I don't think there's any other way to... Oh, hold on a second. It does factor nicely. I forgot the 2. In other words, 5x times 2x is 10x squared. And now once I make that a 2x, it does give us a middle term of 17x. So this one does factor nicely.
Okay.
So the final answer is there's your 3 linear factors.
Okay. Thank you.
You're welcome. All right, Tim.
Have a good night.
You too.
Okay.